Hello and welcome to a video on carbonyls for Unit 4 Chemistry. So this involves aldehydes. And so the C double bond to the O is at the end of the chain, and ketones is in the middle. Now, smaller carbonyls are soluble in water as they can hydrogen bond as well. So when you're with regards to drawing them, okay, you will observe when you're drawing them that oxygen is more electronegative, hence this delta negative and the delta positive or delta plus, and which opens it up to attack from nucleophiles, and hence it undergoes a mechanism called Nucleophilic Addition. Okay, and you're going to need to know how to do that. I've done a video on all the mechanisms, so you can view that. Now, regards to oxidation, which can be done with in acidified solution, K2Cr2O7, so potassium dichromate, and so we have a primary alcohol goes to an aldehyde, which goes to the carboxylic acids. We have a secondary alcohol which goes to a ketone and can no longer be oxidized from there, which is a basis of quite a few chemical tests. So you can use that in your exam as well, because it will ask for that. And obviously tertiary alcohols do not oxidize. Okay, and that's because there's no hydrogen atom attached to the same carbon as the hydroxyl group. So, and then what you're also going to want to know is obviously in this oxidation. Let's take this one as an example. It's going to go from orange to green, and as you may know from Unit 5 Chemistry, it's due to the different oxidation states of the chromate of the it's due to different oxidation states of the Cr atom, and an irrelevant equation you may want to just get into your head or do some further research on is this. This is a general form. I would write it in a longer line, but I'm unable to. And that just shows you. Okay, so you can observe here a change, and so we can use Tollens. A test I always say is just Tollens reagent. Okay, for a chemical test to distinguish between aldehydes and ketones. For reduction, you want to use this NaBH4. Don't mean to join them. I don't like that. Okay, use that for your reduction. It's what supplies the H. It's called sodium tetrahydroborate. Not that you need to know that. Now you can also do catalytic hydrogenation with Ni, so nickel, and a H2, so hydrogen catalyst, and this is RCHO plus H2. Okay, and it just goes to RCH2OH, and it's because it's reduction. So you're going from your aldehyde, or in this case your aldehyde, to the alcohol. Okay, this is under high pressure. Now, you also need to know that this COO is planar, and this leads to the formation of chiral centers which you hopefully recognise with the word optical isomers, or that phrase rather. And because it's planar, it gets attacked equally from both sides, which causes it to make these racemic mixtures, okay, which have got equal amounts of both enantiomers, the positive and the negative enantiomer, and that's what a racemic mixture is. You also need to know that KCN is the reagent you want to use for this nucleophile, okay, and obviously that leads to the formation of hydroxynitriles. A couple of times people have gotten to include that hydroxy. It is important that you do include that, okay, because it's nucleophilic addition, okay, addition. Okay, and so now we're on to sort of the carboxylic acid stuff. Okay, so that's what it is for aldehydes and ketones. For carboxylic acids, say we've got, you know, our standard carboxylic acid, and as a and this is its more stable structure. Okay, that's the best way. You'll see it drawn like this. Okay, cause this to have equal bond length. This would be the shorter bond, the carbon to oxygen double bond, but in the delocalized form, the more stable form, it's more stable because of these delocalized electrons, and you can see it. These are the electrons spread out here along there, and obviously that releases the H plus, causing it to be a bronzed-Lowry acid. Now these cannot be oxidized, okay, excluding methanoic acid, which is basically, if you draw out the structure, you'll realize why I think it's quite a good idea for you guys to do that. Now, if we increase chain length, okay, we can increase the electron density being pushed onto this COO minus, okay, and so this is due to the inductive effect. The alkyl groups are releasing electrons, okay, and it causes the increased electron density around this area, okay, and actually this makes the acid less strong as it's more negative, because obviously H plus being more attracted. Now you can add Na2CO3, and this is the test for the presence of the carboxylic acid, and it produces the effervescence of carbon dioxide. Okay, and so just want to go back to the theory that I was on about before. If you add a chlorine, okay, because it's withdrawal effect, you'll actually make the acid, you'll make it a stronger acid, okay, because it won't be as negative anymore, because you'll be pulling electrons, okay. So I meant to say that's more stable. The less negative is more stable. The more negative is less stable. Sorry, I actually got that wrong. That's my bad. I said it wrong. Sorry about that. The formation of esters, okay, is a carboxylic acid and the alcohol, okay, and that's an equilibrium of an ester plus water, okay, goes under H plus, which is why you'll see it with the catalyzed with H2SO4 concentrated. You can hydrolyze it with the with an acid. However, that's an equilibrium, and so it's essentially doing it with water, and it's basically doing this, okay? But if you do it with NaOH, it actually goes to completion and forms the alcohol and carboxylic salt. Use of esters are perfumes, flavorings, plasticizers in polymers, stuff like that. And you'll see you can actually do the formation of glycerol. It's an equation, and I'm not going to write it out, but you need to memorize that from your textbook. You just need to memorize it, and you also use it to make biodiesel by reacting it with like a methanol or something like that. These long chain fatty acids. You need to be able to do that as well. I might do a separate video on that because it's quite content based, so I'd write it out again. Okay, well, thanks for watching, and hopefully this is a quick review video.